Welcome to the Interplanetary Podcast, putting the ace back in space.
The Interplanetary Podcast. The exploration of space for the benefit of all mankind. Your hosts here in London, Matthew Russell and Jamie Franklin.
So, welcome to the weekly podcast, as it is now, Jamie.
Weekly?
Weekly.
Whoa. The idea being, listeners, is that, whilst I'm sure all of you love a 3-hour podcast, we're just trimming things down for you. But there's so much going on that we're just going to do it weekly. Matt, is this show number 9?
Yeah, it's show number 9.
We're almost in double figures.
Totally in double figures.
Oh, my goodness.
Next time.
Next time. Welcome, everybody, to the Interplanetary Podcast, show number 9. So, Matt, what's been going on?
Let's get the really big news out of the way as quickly as we possibly can.
You're not going to mention Trump, are you?
I am going to totes mention Trump.
Go on, then.
Do you think it's more depressing for Europeans than it is for Americans?
Not at all. I think everyone in the world should be depressed. But hey, it's only for 4 years. It hasn't started well with him appointing lots of climate change deniers to be on his board.
No, that isn't good news, is it? But, maybe that's where NASA can play a big role, because, of course,
Let's hope so.
They have their Earth Science division, which is apparently a little bit under threat, because they're sort of saying, well, should NASA really be doing Earth Sciences at all? Maybe that should be handed over to the United States Geological Survey, the USGS, of course, or over to the National Oceanic and Atmospheric Administration.
Easy for you to say.
What does a Trump administration mean for space? Well, there's been some rumblings, haven't there? There's...
Yeah.
It looks like they're going to take a bit of a hard line, I would imagine. But it's the sort of vainglorious thing that Trump might seize upon as a way of making his presidency seem remarkable in a sort of JF Kennedy kind of way. So,
right. Yeah, let's just say I'm sceptical at best. We can only just hope and not panic too much until things actually start to happen. And then I think the right thing is to do everything we can if these things do or don't happen. Does that make sense?
But there was a guy in the Trump campaign called Walker who said that there was a sort of 9 key aspects to their space program that they wanted to and the one was a commitment to global space leadership. And that's going to be difficult you can see that China are hot on the tails at the moment. Yeah. And the fact that Russia can't get men into space, people into space at the moment is a worry for America.
I mean, Trump does seem that guy that would just want to win, he just loves winning. And I think that, that could be quite a good thing for NASA, because it sounds like he just wants to be better than every other country at everything.
Absolutely. I think that one of the real... I would think that Trump will find it embarrassing that Russia and China are able to get people into space and America can't. So I'd imagine that that's going to really rile him. There's one thing. There's a few other things in their 9-point plan. But I wonder if there's going to be a shift back to the moon.
You reckon?
Yeah, I think they're going to... this is now an opportunity for... a long, hard look at the ARM program, the asteroid retrieval mission. ARM.
Yeah.
And I think they're going to have a look at that, and I think that's going to be the sort of thing that gets cancelled. And remember, they've got this big SLS, the giant new rocket space launch system that needs to have a mission. It needs something to do. Otherwise, that's going to get scrapped, and that'll be super embarrassing. So they need...
That would be a shame.
Yeah, so it's either Mars or it's either the Moon. I think Mars is too early, so I think we're going to see a lot more concentration on the Moon in the next couple of decades.
I wonder what's going through Elon's head. Do you think he needs to worry? I doubt it, does he? He is getting a lot of support from NASA, though. I mean, let's hope that stays.
Remember, Elon Musk represents a lot of things that Trump represents, which is Americans making American goods and supplying American jobs. SpaceX itself builds everything in America.
That's true.
and is totally self-reliant, and so whereas United Launch Alliance gets their engines from Russia, as discussed with David Baker last podcast. So in some ways, I think Elon Musk represents a kind of Trump dream. It definitely, that kind of company, I think Trump will dig.
That is kind of true. Let's just hope he doesn't use all those solar panels to blow up the Middle East, eh?
Yeah, I mean, the thing for me is anyone that is a climate change denier is often doesn't have the critical thinking to be able to really understand science, and I think that maybe science will be in a bit of trouble.
Yeah, well, scarily, he said, well, it's snowing in New York. We need global warming. And that wasn't a joke. I mean, this is terrifying, isn't it?
Yeah, I mean, you could... Let's just hope that is rhetoric and a kind
absolutely,
of a cartoon.
Absolutely.
So let's move on. Now,
Let's move on,
because we just won't know whether Trump's a good thing or a bad thing for a bit, will we? I don't think.
Exactly. Nothing.
There's a really interesting article. NASA space telescopes pinpoint elusive brown dwarf.
The brown dwarf. Yes. Okay, Matt. So if our listeners haven't heard about this brown dwarf, can you give the background?
Well, yeah. I mean, a brown dwarf, I suppose, is a little bit like a failed star. So Jupiter in a way is almost a failed star, where it's massive enough that if there was enough gravity at the centre pushing everything together, then fusion would start and it would become a star. And a kind of brown dwarf is very much like that, where it's not quite turned into a star. It's a giant planet, really, that's not quite a star. It's sort of in between.
Yeah.
And this story is about is three things that are interesting in this story, I think. Is brown dwarfs themselves are interesting. And also interesting is microlensing events. And this is when something very, very massive, like these brown dwarf stars, go in front of other things and magnify the light. So you can imagine that they're just like a lens, where it bends the light in such a way that when it passes in front of something bright, it makes the brightness increase.
Wow, okay.
So these microlensing events mean that you're able to see things that are too dark to see with a telescope.
Yeah.
But they reveal themselves by acting as lenses with the bright stuff behind them as they pass in front.
Interesting.
Now, the second part that's really interesting is that there's two telescopes involved with this. There was the Spitzer Space Telescope.
And the Swift.
The Swift, yeah. Now, Spitzer is an extraordinary telescope that is 1 AU away from Earth. Now, 1 AU is an astronomical unit, which means the distance between Earth and the Sun is an astronomical unit. So this thing is the same distance away from Earth doing its... and it's a space telescope, and it trails around Earth in an orbit around the Sun. And the Swift Space Telescope is in near-Earth orbit. And why that is significant is that they're so far apart that when they look at this microlensing event, they can get parallax in the same way that you can tell how far a tree is away.
Is parallax like when you've had too many rum and cokes down the pub?
It's more like when you have too many Cool Mints.
Oh, right.
Yeah, so these two space telescopes were used to sort of work out the distance to this brown dwarf, and I thought that was really interesting.
That is very cool. I mean, wow, that is amazing. Telescopes, the biggest telescope in the world, right, has been completed. Am I right?
It's not the biggest telescope in the world. It's the biggest future space telescope. So this is a space telescope that's going up.
Ah, okay. But it will be the biggest in space.
In space, it will be by far the biggest. Yeah, when you see a picture of Hubble next to
the James Webb Space Telescope,
next to the James Webb, then they are almost a completely different scale. With telescopes, it's all about the surface area of the mirror that's capturing the light. And even a small change in radius actually makes an enormous amount of difference in the light that it collects because of the pi r cubed. So there's a cubed multiplier in there that means that you get an enormous amount more light for a small increase in radius.
So when's this thing planning to be put in orbit? Do we know?
Yes, so it looks like launch will be in about 2 years' time.
Aha.
Now they've kind of completed building it. So they've built this thing, and there's some glorious pictures on the internet of, and on obviously NASA's picture of the day, etc., of the finished James Webb telescope. And it's made of several hexagonal gold mirrors that all fold up.
Very nice.
Yeah, and they all fold up, and they sit on a massive deck of radiation-proof material, almost like sails. And that then sits in a Lagrange point a very, very long way away from the Earth. So what that means is that when they launch it... See, I find this really interesting because this is 20 years of work, and obviously it's one of the most expensive objects ever built. It's an enormously complicated thing. But what is going to be very, very stressful is this thing has got to sit on top of a rocket. It's got to be launched, and then it's got to make its way over to this Lagrange point, and then unfold, and then start working properly with absolutely no faults in it whatsoever.
Yeah, that's terrifying.
Well, particularly when you start reading about the tolerances of these things. So the mirrors have tolerances where if they're slightly out by the width of like quarter of a hydrogen atom or something, it all goes wrong. It doesn't. Just like Hubble when it first launched had that focusing problem, where the mirror was slightly out, which meant it was fairly useless. And they thought, well, this is a disaster until someone was able to go up in the space shuttle and fix it. So Hubble was a complete flop when it was first launched, and pretty much, if it had remained that way, NASA would have been in some serious funding trouble because it would have been such a total flop.
Yeah.
Whereas,
well, there's really not much room for error here, is there?
I would say that there is no room for any error whatsoever. So this is a profoundly ambitious project.
It's things like this that people worry about, because if it blows up or it doesn't work, I mean, the time and the money that's been put into something like this is enormous, isn't it?
Yeah, I mean, we're talking 20 years of work at the very minimum. Remember these things... like when we were talking to Gerhard from ESA about Rosetta. So when we were talking to Gerhard about Rosetta, you realise that this thing had really been in the offing for an entire working life of someone, and I'm sure that's exactly the same with the James Webb Telescope. It is a lot of people's entire working life, and of course this all rests on a rocket. On a massive explosion that's got to get it into space. It's phenomenal, isn't it?
It absolutely is phenomenal, and it does look. You need to. We'll put links up to the pictures of it. It does look beautiful, like a big giant honeycomb in space.
Yeah, and there were some very interesting pictures where one of the pictures had a blurred out section of the James Webb Telescope, and it turns out that there's a kind of secret mechanism. That's proprietary to the American military to actually kind of keep the secondary mirror in focus. So this is cutting edge.
This is something we don't want those commies to see. Love that. I'll tell you what I want to talk about, Matt. The egg rock.
Yeah, the egg rock.
Tell me about the egg rock.
So the egg rock, it's something that got my eye as Curiosity trundled its way across the Martian surface. It stumbled across this big black rock that looked nothing like everything else on the planet that it's come across so far.
Any clues?
Well, it fired its laser at it, of course, and sniffed it with its all its little instruments after firing this laser at it.
Licked it.
The theory at the moment is just like other black rocks that we would see on Earth. It's actually comes from either the asteroid belt or maybe the Kuiper belt. It's a meteorite basically that's landed on the Martian surface. So I wonder if that's a first. I wonder if that's the first meteorite that's been found lying on the surface of Mars by any of these rovers.
Absolutely.
But again, it's a great little picture of a weird looking object on Mars, which undoubtedly Yeah, well, there'll be millions of YouTube clips of how NASA are hiding secrets of...
I was going to say, what are the conspiracy theorists saying? Is it a skull? Is it... what is it?
well, it's proof. It's proof of a alien civilization on Mars.
Of course it is. Yeah. Get the Event Horizon.
So yesterday we had the glorious Atlas V.
Atlas V, yeah.
And it was carrying a satellite called Worldview 4. Now we have actually mentioned this on a previous podcast because it's massively delayed. This thing, it was supposed to be June the 29th, then September the 15th, then September the 16th, and now it's finally been launched. Now it's something. When you look at the stats of this, it's another space telescope, but this time instead of looking out to space and trying to, unlike the James Webb that will try and look to almost the beginning of time, and because it's so powerful, we might even be able to see atmospheres on exoplanets, that kind of thing. Worldview 4, of course, its name suggests that it's going to view the world, not exoplanet worlds, but our own world. And it's going to be flying at about 617 kilometres high. And it's got a 30 centimetre resolution. Well, which is phenomenal, isn't it? That means
that's insane.
Yeah, so it's going to get some pretty neat snaps of the Earth, and it can skew 200 kilometres. So if you want to look at something, it can sort of go from London to Manchester in less than 10 seconds to retarget. And it's going to add almost 700,000 square kilometres of image data every day to the library, which I think...
Wow.
So this thing's a very, very sophisticated satellite, and that went up on the Atlas V. And the Atlas, just so you know, the Atlas V is the same rocket that launched the Mars rover, Curiosity, we were just talking about, New Horizons, that went past Pluto, and more recently the OSIRIS-REx mission. So this thing is, that is a workhorse. And do you know what's amazing about the Atlas V? It's had a perfect mission success rate since...
Don't jinx it, Matt.
On its maiden launch in August 2002, perfect. And I guess that's United Launch Alliance don't tinker around as much as Elon Musk do with the design of that. So
it's kind of similar to Gary Lineker's record with getting no yellow cards or red cards.
That's exactly right. You kind of almost want ULA to retire the Atlas V so it finishes with that 100% record.
Yeah, that's what you would want. Imagine the no claims bonus you'd get back. Brilliant.
Well, I wonder what rocket James Webb will launch on. So one thing we should mention is just how many launches the Chinese have been doing recently.
What they've been up to?
Well, the most recent of which is the Long March 11, and as we've discussed, Long March is after a long march that the Red Army had to make to get themselves out of trouble. So it's not a boring name at all. Unlike so Long March 11, it's only the second time that one's flown, and it's just one great big solid rocket booster that launched a couple of satellites, one being an X-ray emission tracker that's going to detect X-ray signals from 26 nearby pulsars being what's left out, a sort of star that spins very rapidly after a supernova. And it's going to create a navigational database. And so what it's doing is mapping all these different pulsars so that when you're out in the solar system or out going to Proxima C, say, you can use these pulsars as a form of navigation. So they're almost like GPS satellites, but natural ones out in space, because they're so rock solid and reliable that you can use them as navigational pointers. And this Long March 11 flew up this X-ray satellite, the XP-NAV-1, to map all these things. And this is going to be a sort of 10-year project.
Take that, Tom.
Yeah, so that Long March 11 launch was straight on the back of the Long March 5
yes,
launch.
which has had its issues.
It has had, it turns out, I mean, Long March 5, this is China's entry into heavy lift vehicles. So we're talking the Delta IV Heavy, the Dragon Heavy, that kind of lift capability, the Ariane 5. So it's so the Long March 5 has been a technical achievement, a massive technical achievement for the Chinese. And it flew, and it looked like it was a pretty amazing flight and went without a hitch. But it turns out, obviously, there were a few problems, even though it was mission success. And I just loved the quote from one of the head engineers that he goes, "Have you experienced such situations before?" And he chuckled and says, "Well, now you know why my hair is all white."
So it sounds like it's been a stressful mission.
I think when you're a rocket scientist and you're firing up rockets, and you've got a fairly strict regime to please, I think it probably is quite stressful, don't you think?
Yes, that is correct. Now let's talk about SpaceX for a minute.
Yeah, well, even though we talked about them a lot, it looks like they finally have confirmed what was a suspicion all along about what actually caused that explosion. So we kind of we had an exclusive on this, didn't we, Jamie?
We did, Falcon 9, bless it.
So, so we had the exclusive. What we thought it was the oxygen actually, not the liquid oxygen, behaving badly in the composite fuel tank.
Yes.
And basically becoming solid and reacting with the carbon composite and blowing up, essentially.
Yes.
Elon Musk calls the problem surprising and said it had never been encountered in the history of rocketry, but it's not completely unexpected, and it had actually already been flagged up. So, it seems that there had been an email where people were already actually worried about this particular thing, and there had been an email that had been sent before this explosion to NASA saying that they were worried about the way that liquid oxygen was being pumped into the tanks, and that there wasn't a recycling unit to make sure that there was an even distribution of heat through the liquid oxygen. So this has already actually been flagged up, and it's with the X-33 spaceship in the 1990s. They did have experienced cracks in the composites when they were using liquid oxygen, and they could never overcome it technically, and that's why that particular X-33 that the program demised. So it's not completely without precedent. So Elon Musk is slightly wrong there.
Yeah, that's a bit of an embarrassing thing, isn't it?
Yeah, I would have thought so.
Yeah.
In fact, a panel of highly respected aerospace experts told NASA 8 months before the accident that the lack of a recirculation pump aboard the Falcon 9 rocket could be a safety problem.
Well, personally, I'm going to call the FBI and get them to check his emails.
Yeah.
Because that's just not right.
Well, of course, it was an internal email because eventually astronauts are supposed to be sitting on top of a Falcon 9. So he's got to get that right, and if there's safety concerns, that astronauts never will fly on the Falcon 9, and Elon Musk has a lot of money, on top of that. Now, Elon Musk has said that now they've found this problem, now they've realised what the problem was, then the Falcon 9 should be flying by mid-December, and so they've already got their manifest to try and get this thing rolling again. They've got a backlog of 70 missions worth $10 billion US, and so we've got SPX 10, 11, 12 and 13 for 2017, and these are the resupply missions for the International Space Station. So it's starting, they're starting to sort of try and break down this backlog of missions. But if they keep having failures, another failure will really, really, really be catastrophic, I would think. So they've got to start getting some more reliability into their rockets.
Absolutely. Good luck, team.
But anyway, next space station crew, we're going to launch on November the 17th. So that's soon.
So let's read some names out. We've got astronaut Peggy Whitson, Oleg Novitsky, and Thomas Pesquet. And that's the ESA, the European Space Agency, obviously will launch Thursday, November the 17th, for a 6-month stay aboard the ISS. That's really exciting.
We don't normally do this, but we got some spacey things that I thought were really interesting. Yes. In the kind of last couple of weeks, we've had both dark matter and dark energy coming under question. A lot of people get dark energy and dark matter mixed up or think that actually they're related, and really they're not.
In layman's terms, Matt, what's the difference?
Well, the difference is dark matter is to do with when we look at galaxies spinning, there doesn't seem to be enough matter to hold the things together, so not enough gravity to stop these things from just spinning and all flying off. In the same way that, if you put some light pieces on one of those things that you have at your house, what are they called? Lazy Susan, is that what they call
You're so posh. I know the one you mean.
If you start spinning your Lazy Susan too fast, all your hummus and your cucumber dips all fly off.
Please don't try this at home.
No, so that's what. If there wasn't any dark matter, that's what would be happening to galaxies. They'd just all fall apart. So there is definitely extra mass out there that we can't see, and the reason why we can't see it is because it's dark. So we have dark matter, and no one really knows what it is. There's quite a few candidates for it. But someone has suggested that maybe it's the fact that we're seeing gravity wrong in the first place, that gravity isn't a fundamental force, but an emergent phenomena. Yeah, so which is interesting, because I'll give you another emergent phenomena, and that's heat. So when temperature, you get more heat as microscopic particles move around. If you understand gravity as not as a fundamental force but as an emergent property of something, then you no longer need dark matter to solve all these problems. Now, this is a radical point of view, but it's gaining a little bit of traction, I noticed, on the internet, and it's not on the internet, but amongst the science community. So I think it's really, really interesting, and this is being spearheaded by Erik Verlinde of University of Amsterdam. That'd be really interesting to see how that goes. Now, dark energy came under attack because in the sort of late 90s, people won the Nobel Prize because they used supernova data to prove not only was the universe expanding, but actually expanding at a greater and greater rate. Now, this was which basically meant that Einstein's cosmological constant was a positive, and it was totally unexpected. Until that point in the late 90s, everyone was expecting the universe to finish in the Big Crunch, but now we know that it's not going to. It's going to suffer heat death. Well, it'll expand until it just turns into nothing.
What a way to go!
Yeah, just rubbish way to go. So that was obviously loads of people won. 3 people won the Nobel Prize for that, for their work on independently looking at supernova and working out this greater expansion. Now they've revisited that data and realised that it didn't have a greater statistical rigour than was expected when you applied it to lots more supernova that have been discovered since. And so it's dropped from 5 sigma, which pretty much is proof, down to 3 sigma, where you've got to be a bit cautious. Where no scientist would say this is now a fact on 3 sigma, and so everyone's going, dark energy's now. It may be that maybe we don't need dark energy, but it's not as simple as that. And actually, it's a classic example about how rubbish the science journalism is that if you look at the data, it almost completely agrees with the late 90s data that got the Nobel Prize. It's just that it reveals that actually, if there's an outside chance that the cosmological constant could be 0, but they didn't win. The Nobel, this whole dark energy didn't just come from this one line of evidence. There's lots and lots and lots of other things in the universe that have been measured by various scientists all over the world that suggest that there's dark energy. And if you bung all that information back into the pot, then you're back to your 5 sigma, this is a fact. So dark energy isn't going anywhere, despite what the newspapers say.
It's here to stay, all right?
Yeah, so it ain't going nowhere.
It's here to stay.
But nevertheless, it's a very, very important paper because scientists will be poring over it about why that is, why that particular stream of evidence has become slightly weakened. So it's not an unimportant paper by any stretch of the imagination, but the way that the scientific journalism has interpreted it is not really entirely honest, as per usual.
And now for something completely different. Matt, I'm going to throw a question to you. You ready? How do you go to the bathroom on the International Space Station? You know I've been wanting to speak about this for quite a few podcasts now. I'd like the lowdown.
Do you know what? I love this one because I think a lot of people get upset by the very question. But at the end of the day, when you actually read the answer, it's actually really, really interesting. And it's a human function that
exactly, we all do it. We just don't do it that many miles above Earth.
This article came from space.com, and I thought this was really interesting. Yeah, so Michael Fossum, who's done a couple of space shuttle missions.
That's not a euphemism for going to the toilet.
No.
Okay.
Yeah, I'm sure he's done way more than a couple of space shuttle missions if it was a euphemism. So
let's read through what he said. Okay, so, for number ones, he said he uses a hose to turn on the suction to pull the urine away. Okay, which is recycled. Here's the interesting thing, which some people may squeam at a bit. It's recycled and used for drinking water.
Yeah. So it gets. I mean, you can't just take loads and loads of water up. So all those sort of things get recycled, so that you get your water from your wee.
Is that why they don't eat asparagus on the space station?
I don't know whether they don't. Only some people's wee smells after asparagus, Jamie.
Really?
Yeah,
I'm one of those people.
It's a gene marker. Oh, I am totally one of those people.
Interesting.
Very interesting. But some people it doesn't affect them, and they don't even know what you're talking about. Sugar puffs or
the Sugar Puffs one? No way. I don't think I've ever eaten Sugar Puffs. I might have to go out and buy some to experiment.
Don't forget the honey mummy.
All in the name of science.
And for number 2, you perch on a solid waste container with a plastic bag in it, and you seal the bag and push it into the container.
Easy as that.
Yeah, and then that container's changed roughly every 10 days. Apparently, it breaks down quite often, once a month. You
wouldn't want anything floating around like that.
Yeah, so it's once a month the toilet breaks.
God, they earn their money that day, don't they?
Well, yeah, as we've discussed, their work's hardly that hard. 5 days on, a few hours here, weekend off.
I love how you think they're slackers.
So yeah, I thought the really interesting one is how you do it on a Soyuz spacecraft. So when you're actually rocketing towards the International Space Station. Now, what's funny about that is sometimes it only takes a few hours to get up to the space station, but sometimes, just the way that the journeys and trajectories are, you might.
Well, if you got to go.
Yeah, well, it might take 2 days, and obviously you've got to go in 2 days. Although what's interesting is a lot of them. A lot of the astronauts have an enema just before the flight to avoid the need for a number 2 on the flight.
Wow.
Yeah, but apparently the Soyuz toilet is very rudimentary and uses an airflow to pull the waste into a collection to collect the waste.
Yeah.
And rather than taking the urine to a tank with pre-treatment, the urine goes into a tank that literally has what appears to be foam rubber that absorbs the liquid.
Blimey.
Yeah.
Like a cat litter tray.
Yeah. And it's just...
See, I always thought that they would wear nappies. Human nappies.
Yeah.
But I guess not.
I don't... Yeah, it doesn't look as though they do. And that's what I thought.
Because how do you get... There must be a quick release, because you wouldn't get out of your spacesuit, would you?
No. Yeah, it's really odd. But the most amazing thing is that the fact that the astronaut uses a handheld device located in the orbital module of the Soyuz to give a little bit of privacy, and the other crew members move into the descent module. while the first crew member does his or her business.
Oh, that's brilliant. They must have some fun. Guys, do you mind if I just... could you give me 5 minutes?
Yeah, it's crazy, isn't it? And Fossum added that few astronauts use the solid waste collection system, which is another handheld device, because of this practice of getting an enema before the flight. So he doesn't know. Someone must have used it though. It's hilarious. Isn't it, that?
Yeah. God, that's someone's job.
That is
facilitating the enemas of nearly departing astronauts. Wow,
Jamie, the most exciting thing that I saw in the news for this week is EMdrive again. Now,
yes,
and I'm actually amazed that this didn't get more coverage actually, because the paper that we talked about not in the last podcast but the podcast before that's going to be released soon has been leaked online, and you can download it from a Google Drive somewhere.
Okay,
which I have done, and it's a very interesting read, and it looks like it does generate thrust. But what I thought was even more interesting is that the IBT, the International Business Times, reported that the US Air Force is currently testing out a version of EMdrive on the X-37B. Now, we've talked about the X-37B before. It's a sort of military space shuttle-looking thing that goes up into space and flies around for years on time and comes back down again.
Yeah.
And apparently the EMdrive's on that being tested right now. And
that is amazing.
Even more extraordinary is the claim that it's actually on the Tiangong 2, the space station that we talked about last podcast.
Yeah.
And the two taikonauts that are on that particular on Tiangong 2 are testing that out as we speak in the month that they've got up on board the Heavenly Palace. So so it looks like China and the US are both interested in this thing, and it's
weird that it's not getting more press.
It is, isn't it? Particularly considering it's a British invention by Roger Shaw. Yeah,
we need to shout more.
Yeah. So, well, I think it's because people are very, very scared that this thing shouldn't really work. So it's one of those things that is like, well, this is too... I don't know whether to touch it because you've got egg on your face for mentioning EMdrive, because it seems such a kind of, it's a bit like those bracelets that channel energy and so that you don't get car sick. It's that kind of ludicrousness. And
my mum gave me one of them as a kid. I don't think it worked that much.
No. And there's that bloke who thinks he can teleport and things like that, and gets a lot of interest with his metal bracelets. So I think it's got a hint of that about it, hasn't it? But apparently not. Apparently there is quite a lot of interest in that.
Well, good on you, EMdrive.
Yeah. Now, something that we've talked about on a couple of podcasts, Jamie, that has finally resolved itself, and that is Muos 5. Remember that one?
Oh, yes, I do.
Yeah, that actually went up on an Altlas V as well. So, it was always going to get up there. It was always going to get up there.
So this is the MUOS, Mobile User Objective System.
That is exactly right. And remember, we talked about it, that it sort of was part of this ridiculously expensive American military satellite system.
That's right.
And it had failed to get into orbit. It was nowhere near its orbit, and its kind of thrusters to get up to that orbit didn't seem to be functioning properly.
Yeah.
But we said that this has happened before, and that eventually they're able to kind of reconfigure these things. Apparently, it has finally made its way to its operating orbit, which is
good work.
Which has maintained Altlas V's 100% mission success rate.
Absolutely, another one. That's fantastic.
And it's in geosynchronous orbit now, as of June 29.
It's my personal favourite orbit.
Well, I believe it was Arthur C. Clarke of British Interplanetary Society fame that first sort of was really banging on about geosynchronous orbit. So that's probably why it's your favourite, James.
That's definitely why it is. You just know me so well. Well, thanks for listening, and as always, please email in your questions. We love reading them.
Do it,
Jamie.
It's been a pleasure having you.
It has been emotional, and we'll see you for number 10. When we will actually definitely be in double figures.